that a rectangle in perspective is a square. The first thing we'll do is we'll set up the same environment as we did last time. So we'll have that generic setup, and you have a video about it so everyone can share that, see that. So we'll start with making an eye level, and because we are, for the sake of time, we'll just say here's the, because last time I explained it, why the 90-degree angle is the best angle, and he will put it here. So we'll call it our station point, and we'll have our vanishing point 1 and vanishing point 2 on opposite ends, and we'll connect it, and here will be our general view space. We're going to ignore right now the 60-degree ultimate space, like the best space to draw. Quickly, 60 degrees is the best because you get no distortions. So when you look out, you see about 90 degrees to the vanishing point 2, vanishing point 1, where you stop seeing. So here's where your just sight ends. You can't see anything past these 2 points. The station point is where you're seeing. So this is you are at the station point. This is your view, and the best view is 60 degrees, where you have no distortions. But right now we're not, since we covered it last time, we're not going to go into depth why 60 degrees and all that. We're going to go into the beginning of understanding how to mechanically draw a cube. Now, to draw a cube has 6 planes, which are squares. So if you're drawing a cube in perspective, you need to place a square in perspective. And this is why we're understanding how to prove that a rectangle is a square in perspective visually. So you'll create a diagonal vanishing point. So you essentially will divide this 90-degree angle in 2. You can use a protractor, place it like this. Oh, I guess I didn't do quite a 90. Sorry guys. So place a 90-degree. I eyeballed it. So this is your near VP2. So here's your here's your space where you're gonna work. And here's a 90-degree angle, and here is your diagonal vanishing point, somewhere in here. So what you will do is you will divide this 90 by 45 and 45, so you'll have a diagonal vanishing point from which you can extrapolate the square in perspective. So the first thing you do is divide the 90-degree angle into equal parts. So 45 and 45 is 145, and let me see here. So here it is. That's your DVP. The DVP is the diagonal vanishing point. So now you want to draw a square. So the first thing you do is you draw 2 lines. You take 2 lines to the different VPs. So where do you guys want to place the square? So one of the corners would be where?
Anywhere.
Okay. So let's say right here. So you take these 2 lines to the vanishing points, and this will be the bottom of your square. or your square in perspective. So here's your second VP. You take this line there. So this will be the bottom part of your square, but you need to know where to put this point. Where would this square be a true square? So the next step is to draw a diagonal from this point. We'll call it X. And we do it to the diagonal vanishing point. Because, why is it called diagonal? Because this is going to be a diagonal on the square. And we'll extrapolate from that the other points on the square.
Okay.
Yeah, so this is why we're calling it a diagonal vanishing point. Last time we covered vanishing points, and we covered the fact that they could be essentially anywhere on this line, the eye level, because it's essentially a line of points from which you can't see, because that is the last point you can see, and then it's horizon. You can't see anything further from that. So we'll call this point X, and we're going to draw to the DVP. And we can use this line to our benefit because it divides the square into two in perspective. So the next step we're going to do is we're going to, one second, sorry. Oh, okay. Decide on the side of a square, right? This is arbitrary. You decide on one side of the square. Say you want to make this side of the square. And then you carry this to the VP.
Oh, you changed the VP.
So what did we just do? We created the setup. We created the dividing vanishing point, which will help us understand where to place other points on the other endpoints on the square in perspective. We have made our first point of the square, and we drove the two bottom lines of it to the vanishing points, to the respective vanishing points. Next, we decided an arbitrary length for one of the sides from which we can decide on all the other lengths based on our setup. So this is the side we decided to give a length to. And now, because a point has crossed this dividing line right here, we know that in order to get this point on this line, we pass VP1 and this point, this diagonal divider. Essentially, this is a line for us. So we don't have to worry about where to place the point, because essentially the DVP will guide us. The intersection between DVP and a line of the square will guide us to the correct point that would make this a true square. So this is a true square in perspective. So this is a true square in perspective. And let me do another one, because I think haven't done this for a really long time. So I'll do a